In this video, we're going to compute the annual percent yield, also called the APY. Here's our formula for the APY, where R is the annual interest rate and N is the number of compoundings per year. So the idea of this measurement is that if we're using compound interest, the number of compoundings affect the total percent yield you get in 1 year. So that's the annual and that's the yield part. So let's compare some of these. We're going to look at annual compounding. This is semi-annual, quarterly, and monthly. So we're given that n equals 1, and we're told here that the interest rate is 8.5%. We're going to write that as a decimal, so that will be 0.085, moving the decimal 2 places to the left, and we're going to round our end results to 3 decimal places. So here, when n equals 1, we have 1 plus 0.085. The number of compoundings is 1. The number of compoundings per year is 1. And then we're going to subtract 1. When we're done, we'll change this to a percent after computing this by multiplying by 100. Okay. So, in general, even though we don't need to here, we're going to start by computing this ratio, adding 1, raising it to the exponent, then subtracting 1. So this is the order of operations. Again, if you have a scientific calculator or a graphing calculator, you can enter this entire expression all at once. Just make sure you use the corresponding parentheses. So we have 0.085 divided by 1, and yes, that's just itself. Then we're going to add 1, and we have this result for inside the parentheses. Raise it to the first power. Again, that's itself, but we just want to do the same process for all of these. Subtract 1 for this part, and multiply by 100 to change it to a percent. And we have 8.5%, which should look very familiar. Now that may have seemed pointless and useless, but the idea is, since this is an annual percent yield, if we're compounding annually, the interest rate is equivalent to this annual percentage rate is equivalent to the annual percent yield. Let's see what happens when we compound twice a year. So we'll have 1 plus 0.085. Okay. We're going to divide the interest rate by 2 because we're going to do half the interest rate twice a year. So the exponent is 2. That's our 2 compoundings. And let's see what we get. So first we'll divide the interest rate by 2. Okay, so that's half of 8.5%. Now we'll add 1. Now we're going to raise that result to the second power. So raise to the second. And then we'll subtract 1 for this part. And now we want to rewrite this as a percent, so we multiply by 100. Okay. And we were asked to round to 3 decimal places, so that would be 8.68. Here there's a 0, but to the right there's a 6, so we're going to round that up to a 1. So 8.681%. Okay. So notice, just by compounding twice a year versus 1 time a year with the same interest rate, we went up by 1/10 and a little bit more of a percent per year. Let's do 4. And change colors so they don't smush together. So 1 plus 0.085, we're going to divide the interest rate over 4 compoundings, so 1/4 of this interest rate per compounding. There's our 4 compoundings. Subtract 1. So we'll start with the interest rate, divide it by 4, add 1. That's this result in the parentheses, so now we raise it to the 4th power. Okay. And then we're going to subtract 1. And then this is our decimal percentage for the APY, and we multiply by 100. So for 3 decimal places, 4 is in the third, 7 is in the fourth, so we'll round up to 8.775%. And now let's see what happens with monthly compoundings. So 1 plus 0.085. We'll divide that yearly amount into 12 equal monthly pieces. We'll compound 12 times, which goes in the exponent. And we'll start with 0.085 divided by 12. Then we're going to add the 1. Raise this result to the 12th power. And then we subtract 1. To change this result to a percent, we multiply by 100. And to 3 decimal places, we get 8.839%. 8.839%. Okay. So the moral of the story is, notice as the compoundings increase, we fix the interest rate. It's the same interest rate for all of them, but the more you compound, the greater the annual percent yield. And if we looked at this, if either of these or if all of these were for 30 years, this compounding would accumulate even more.